Alright, looking at graphing systems of inequalities, we sometimes run into graphing linear absolute values. Now, this is really very similar to graphing a linear equation, except now we've got an inequality sign and we've got the absolute value, which just means instead of a line, we're going to have a V shape on our graph. We still graph them just the same. The first thing I'm going to take care of is this graph right here. And I always like to make my trusty table. I'm going to label this with the coordinates for my vertex, so I remember that. And then just in another color, I'm going to put y, absolute value mx plus b plus c. Well, I know clearly that c is 0 because I'm adding 0. The only thing I can add here is plus 0. So I can put in 0 there. The number for b is -3, so the opposite of b would be +3. And the value of m is 1. So if I put over 1, 3 divided by 1 is just 3. And I know my vertex is at 3, 0. So I'm going to come over here, I'm going to put 1, 2, 3 for x, 0 for y. Now I can pick any other point to start to find out how to graph this. I'm going to pick 0 because it typically makes things pretty easy. So if I put 0 in, then y equals absolute value of 0 minus 3. And it doesn't matter that I'm using an equals sign because all I'm doing is trying to find the y. 0 minus 3 is -3. So y equals +3 because the absolute value of -3 is 3. So here I have a point at 0, 3. Now in order to go from this vertex, okay, so my vertex was at 3, 0. Put a little v next to it so I remember. I went from here 1, 2, 3 over, and 1, 2, 3 up. So now I'll go 1, 2, 3 the other way, and 3 up again. This will give me my V shape. It's going to look like this. I want to go back and reference, do I use a solid line or a dashed line? It's going to be solid because I have or equal to. And again, even though it's a V and it's pretty obvious which one I'm doing, good practice is to label your inequality, y greater than or equal to the absolute value of x minus 3. Now if I'm looking at this, I just need to now, because of the absolute value, test a point. And we can still test 0, 0 because it's not on the line. 0, 0 is clearly off the line. So let's put both 0 in for y and 0 in for x. You get 0 is greater than or equal to -3. 0 is greater than or equal to 3. 0 is clearly not greater than 3. I don't know about you, but I'd much rather have $3 than $0, so I know that's not true. And if the point outside the V is not true, then everything outside or underneath the V is not true. And everything inside would be true. So we shade what we're going to call the inside of the V. And maybe I'll leave it shaded like this. that area is true. Everywhere outside the graph does not make this true. Now let's go and let's look at y is less than 4. This is another one of those where it's actually pretty easy, because all you're going to do is go put your marker or pencil or pen on 0, 0. You're going to go to where y is 4. You can put your dot. Good practice always to have 0 for x, 4 for y. And you're just going to come right across and draw a horizontal line. Here we've got a horizontal line. We're going to label it with y is less than 4. And I know that my y values are less than 4 underneath, because my y value here is -1 and -2, and -1, -2, -1,000,000 are all less than 4. So you're going to come through and you're going to shade all this area going straight down as much as you want, that's okay. But if you remember, when we graph systems of inequalities, what we're looking for is the area that both are true. Okay? And the area where I can visually look and say, I see some red and some black in this little triangle here. So my feasibility region is right in here. And the feasibility region is the solution to the system of inequalities. So we came through, we graphed both our absolute value and shaded, our line and shaded, and then we said this is the feasibility region right in this little triangle here. Not up here, not down here, not over there, not here or here, but just in this little triangle. That's how you do an absolute value in a system of inequalities.